Okay, let's look at this past paper question from June 2019. It's about fertilizers. It says the 4 steps in the manufacture of an inorganic fertilizer are shown below. These steps are not written in the order in which they occur. So we're just going to skip those now. It says write down the correct order in which the steps occur in the preparation of inorganic fertilizer by using the numbers 1 through 4. Okay, so what we have to do here is we have to go through this question and decide which of these is the first step, which of these is the last step. So if we have a look here, step 1, sulfuric acid reacts with ammonia to produce ammonium sulfate. This has got to be last. Okay, why has it got to be last? Because the fertilizer is the end product, so we can't be doing that. Sulfur dioxide reacts with oxygen to produce sulfur trioxide. This looks like interesting. It's quite near the beginning. Oleum is diluted with water to produce sulfuric acid. This is later. Sulfur trioxide is bubbled into concentrated sulfuric acid to produce oleum. If you look here, here's oleum and here's oleum. Step 4, even if you don't know the process because you haven't remembered it, you can't be diluting the oleum until you've made the oleum. So just by pure logic, you know step 4 has to come after. Step 4 has to come before step 3, because in step 3 you've already starting with oleum, and in step 4 you're ending with oleum. And the same thing here with step 2 and step 4. Here sulfur trioxide is a product, and here sulfur trioxide is a reactant. So fairly obviously this step 2 has to be coming before step 4. Okay, so let's have a look here, put these in order. This one has to be first. Okay, step 2, because we are producing sulfur trioxide. Then we go to step 4, because we're now taking the sulfur trioxide to produce oleum. Then once we've made oleum, we make sulfuric acid in step 3. And then once we've produced the sulfuric acid, we're going to now use it as a reactant in step 1. So even if you can't remember the process, apply some logic and check what is a reactant and what is a product, and then you can work it out by logic. Now it says to you, balanced chemical equation for step 1. Remember, anytime it says balanced chemical equation, remember that you must focus on, to get the marks, if you don't know how to balance it, and you know it's going to take you ages to balance it if it's a hard equation, focus on getting the marks for writing the reactants, drawing the reactant arrow, and then giving the products. Okay, so for step 1 it says sulfuric acid, which as you know is H2SO4, and then we're going to react with ammonia, which is NH3. Now this is very important. Once you've got your reactants, say for instance you don't know what's the formula for ammonium sulfate, but you do know the formula for the reactants, make sure you write the reactants and draw your arrow, so that if anybody comes to mark this, you can get a mark for knowing which are the reactants. Now it says ammonium sulfate, so remember ammonia goes to the ammonium ion, which only has a charge of +1, and the sulfate ion is SO4 with a charge of 2-. So what's going to happen here is, look, I'm going to put in the charges here, okay, just for the moment. If you have a look here, this is not balanced because the ammonium's got 1 positive and the sulfate has got 2 negative. So this is not a neutral molecule. That's what I mean when I say it's not balanced. It's not a neutral molecule. So what we want to do there is make 2 positive charges, okay, and they will balance the 2 negative charges. So now we have ammonium sulfate. But if you look here, I'm going to need 2 ammonias to do this, okay, and this is now balanced. If you weren't sure how to balance it, you can still get 2 of the 3 marks for showing me you know the reactants and showing me you know the correct chemical formula for the product. Now it says to the name of the catalyst used in step 2, which is when you make sulfur trioxide. You have to learn this. The catalyst is vanadium pentoxide, or sometimes they say vanadium 5 oxide with the 5 in the little stock notation brackets. Now it says to you a balanced chemical equation for step 4. Remember, focus, reactants, products and then balancing, because you can get 2 of the 3 marks. Step 4 says sulfur trioxide, which is SO3, is bubbled in concentrated sulfuric acid, which is H2SO4, to produce oleum. So say now you're confused, you don't know what oleum is. If you just write SO3 plus H2SO4 and an arrow, you can have 1 mark. The arrow is showing the examiner that you know those are reactants. So this is the formula for oleum, and as it is, this is balanced just as it stands like that. Okay, why now? This is 10.1.4. Sorry, I wrote 10.1.5. Why now does it say to you, why is sulfur trioxide not dissolved in water in step 4? Why do they put it into the concentrated sulfuric acid? Remember, this sulfur trioxide, if you put it in water, it's a dangerous reaction, okay? It's very exothermic, and it makes those fumes, okay? And those fumes are basically sulfuric acid fumes, so they are corrosive fumes. So you need to say something here about it makes corrosive or dangerous or very exothermic fumes, something like that. Then it says to you in 10.2, okay, let's change the pen color. Okay, in 10.2 it says to you, the diagram shows a bag of NPK fertilizer. One of the numbers of the NPK ratio on the bag is labeled as X. Here it is here. Okay. If the mass of potassium, okay, remember the mass of the potassium has to be the last one because it's NPK and K is potassium. If the mass of the potassium in the bag is 3,3 kilograms, calculate the value of X. Now, what's the first thing to remember here? This bag goes X, 1, 2, 20 in brackets. What is the very, very first thing to remember? The very first thing to remember is that this 20 here is telling you how much of this bag actually contains fertilizer. This bag is only 20% fertilizer. So the whole bag weighs 50 kilos, but of those 50 kilos, only 20% is actually fertilizer. So 20% of 50 kilos is 10 kilos of fertilizer in the bag. Okay, now of those 10 kilos, 3,33 is potassium. So what you just have to do here is remember this is a ratio. This X12 is a ratio. So the total ratio, okay, the total ratio is going to be X plus 1 plus 2, which is the same as X plus 3. So then if you want to know what ratio is the potassium, okay, the potassium is the 2. So the potassium is 2 over X plus 3, okay? So the 2 over X plus 3 is going to be equal to 3,33, okay? Well, it's not actually equal to 2,33. It's 2 over X plus 3 of the total mass of fertilizer in the bag is going to be equal to 3,33. So this 2 over X plus 3, see this over here? That is the ratio, but we know that it is 2 potassium over the total ratio of only 10 kilos of fertilizer in the bag. So now if you do algebra here, you'll get, must I show you the algebra? So if we say 2 over X plus 3, it's going to be equal to 0,333 because I divided by 3, and then I get 2 equals 0,333 multiplied by X plus 3. I've just brought the denominator over, and either way, and then you get 0,33x plus 0,999. It works out here. Do the algebra. X equals 3. And that is what the question is asking you. What is the value of X? So it's 3 parts nitrogen, 1 part phosphorus, and 2 parts potassium. So X equals 3. And that is the end of the question.